Okay, so for number 9, that's kind of a handful compared to the other ones. So there's a couple of things we got to be good at before we jump into something like number 9. So you've probably seen this many times. Okay, y equals mx plus b, where this represents the slope, m, right? And then b represents the y-intercept. Now, if I just make some stuff up, I'm not going to do number 9 just yet. I want to do an example or two. If I write something that looks like this, okay, and if I ask you, okay, what's the slope? You say, the slope is this, -4. Okay, and what's the y-intercept? The y-intercept is 11. Okay, so if I give you something that looks in this form, you can identify m, and you can identify b. But what if I write an equation that doesn't look like this? Right? What if I write an equation like this? Okay, if you look at this equation, I mean, we have the same kind of stuff. We have x's and y's. But if you look at this, and I ask you, hey, what's the slope? It's not as obvious as this one appeared, because here, this was in y equals mx plus b form. This is not. So how do you take an equation that looks like this and change it to make it look like something that looks like this? Okay, well that means, notice, y equals mx plus b has the y by itself. So in this one here, I'm going to mess around with this stuff to get this y by itself. So first I'm going to take this 2x and move it to this side. So I'll do that by going like this. Minus 2x, minus 2x, okay? Okay, so here these are gone. And this is 6y that falls down, equals, I can't really combine these, because this carries x's and this is just the number. Now let me take these x's, that's negative 2x, and I'll write it first. And then after that, I'll follow it by the 18, which is positive. Okay, so 18. Okay. So now let me get this y by itself. Now this is 6 times y. So I'm going to divide, because that's the opposite of multiplication, right? I'm going to divide by 6, these are gone. And now I have to divide this and this by 6 as well. So this is y equals, that reduces to 1 over 3. Well, negative 1 over 3. You can attach the x on the side, and that's positive 3. So this equation that I wrote here, I did what I did, and I made it look like this. See, now if you look at this, and I ask you, hey, what's the slope? You can say, the slope is negative 1/3, and the y-intercept is 3. So if they give you an equation that looks like this, we have to know how to write it in y equals mx plus b form. Okay, one more thing to look at is something like this. This idea of parallel versus perpendicular. We know what parallel lines should look like, right? If you have a line that runs like this, then a line parallel to this one should look something like that. Okay? So parallel lines, we know what they're supposed to look like. But what if I cover up these parallel lines? What if instead of me giving you the graphs, what if I gave you just the equations and the numbers? How can you tell what parallel lines look like if all you have are the equations? Okay, so here's an example. Okay, suppose you have an equation that looks like this, and another one that looks like this. Okay, if you look at these two equations, they're both in y equals mx plus b form. But more than that, they both have the exact same slope. Okay, and these are different. Okay, but these are the same slopes. Now, if you have two lines that have the same slope, you're dealing with parallel lines. Okay, now for perpendicular lines, a visual of perpendicular would be something like this. You have a line that runs like that, and something perpendicular to that would look like this. Where they cross, but when they cross, they do this. They create 90 degrees. Okay? So similarly, what if you don't have the visual of perpendicular lines? What if I give you just the equations? So here's an example. I'm being totally random here, but it works. Okay, so for perpendicular lines, you notice, okay, so they're both in y equals mx plus b form in my example. But what do you notice about the slopes, right? Whatever one of them is, it seems like the other one is just the reciprocal of it and the opposite sign. Right, and these are different, but these aren't that important. But for the slopes, they're the same numbers, it's just they're upside down of each other, they're reciprocals of each other, and they're opposite signs. It has to be both. Different signs and reciprocals. And if you have that, then you're dealing with two lines that are perpendicular. Okay, so to actually start number 9 now, there's that one equation that they give us. It says something like 5x plus 11y is equal to 92. Okay, so that's kind of random, but okay. So this is an equation this is not our equation, but we're going to be using this guy for something. Now, before anything, when we look at this is in standard form, but I want to rewrite this into y equals mx plus b form, and we saw an example of that just earlier. So now let's get this y alone. So I'm going to subtract these 5x's here and here. All right, these are gone. So I have 11y is equal to a negative 5x followed by a positive 92. Now I need y alone, so I'm going to divide by 11. These are gone. So y is equal to negative 5/11 x plus 92 over 11. Now if you look at this equation here, the only thing that matters to me is the slope. Now what's the slope of this equation? The slope is negative 5/11. So the slope m is equal to negative 5/11. We're going to be using this guy for part A. So for part A, we're supposed to write an equation, right? An equation that is parallel to this guy. So we're going to be using this slope because we are parallel. Okay, so for part A, the slope we're going to use is this. For part B, notice it says perpendicular. So what do I have to do to this slope to have something that's perpendicular? You turn this guy upside down and you switch the sign. So for part B, the slope I'm going to use is a positive 11 over 5. Now the point that they give us, there's a negative 1, 4 given to us. So for both parts A and B, we're going to be using the point negative 1, 4. Okay, so for both parts, I'm going to use this point. So for part A, this is my slope and this is my point. For part B, this is my slope and this is my point. Now I have to actually build my equation so we can actually finish this problem. Okay, and so now let's go for the answers. So this is the stuff we use for part A, right? This is our slope and this is our point. Perhaps you've seen this equation before. This is called point slope. Okay, so we can use this equation to construct our answer. Now this is our slope m, which goes right here. Okay, now this point, this is x1 and this is y1. So I can take this x1 and put it right there, and I'll take this y1 and put it right here. Okay, where this stays the same and this stays the same. So if I plug all this stuff into here, I get y minus, my y1 is 4, equals m, which is that, times x minus, and then my x1 is negative 1. So there's a double negative going on right there, right? Because this negative is this one, and this is this x right there. So these become positive. Let me write this again without the two positives. So this is just y minus 4 equals negative 5/11 times x plus 1. Now your teacher, I'm not sure how picky he or she is, but this is an equation. And this is not in y equals mx plus b form. But to turn this into y equals mx plus b, you'd have to do a couple more steps. But if this is acceptable, then that's your answer. That's an equation, and it satisfies the requirements for part A. So for part A, this is what I would submit. Okay, now so for part B, again we'll use this same point slope formula. Okay, where now for part B we have our slope and we have our same point. So again, let's plug these in just like we did for part A. So this would be y minus y1, which is 4, equals m, which is now 11 over 5, times x minus the x1, where this just becomes plus, right? So this would be y minus 4 equals 11/5 times x plus 1. And again, this is in point slope, which is acceptable. Now if the teacher says that this is not acceptable, that your answer must look like this, you can convert something that looks like this into this in 2 steps. But if this is acceptable, then I would turn this in. If the teacher says it's got to be like this, then just hit me up and I'll show you how to go from here to here. But this is the answer for part 9b. This is our equation.